Hello, psychology scholars! Welcome to our third lecture for Chapter 2, Psychological Research. In this video, we will continue to focus on how psychologists conduct research. More specifically, we will discuss correlational and experimental research methods. Correlation measures and describes the relationship between two or more variables, but this relationship does not imply cause and effect. For example, a correlation can measure and describe the relationship between smoking and health or the relationship between income and educational levels. When two variables are related, it simply means that as one variable changes, so does the other. We can measure correlation by calculating a statistic known as a correlation coefficient. A correlation coefficient is a number from -1 to +1 that indicates the strength and direction of the relationship between variables. The correlation coefficient is usually represented by the letter R. The number portion of the correlation coefficient indicates the strength of the relationship. The closer the number is to 1, be it negative or positive, the more strongly related the variables are, and the more predictable changes in one variable will be as the other variable changes. The closer the number is to 0, the weaker the relationship, and the less predictable the relationships between the variables becomes. For example, a correlation coefficient of 0.9 indicates a far stronger relationship than a correlation coefficient of 0.3. If the variables are not related to one another at all, the correlation coefficient is 0. The sign, positive or negative, of the correlation coefficient indicates the direction of the relationship. A positive correlation means that the variables move in the same direction. Put in another way, it means that as one variable increases, so does the other. And conversely, when one variable decreases, so does the other. For example, as level of education goes up, so does the amount of income, and vice versa. A negative correlation means that the variables move in opposite directions. If two variables are negatively correlated, a decrease in one variable is associated with an increase in the other, and vice versa. For example, as the number of cigarettes consumed goes up, health goes down. As I mentioned earlier, correlations have predictive value. Imagine that you are on the admissions committee of a major university. You are faced with a huge number of applications, but you are able to accommodate only a small percentage of the applicant pool. How might you decide who should be admitted? You might try to correlate your current students' college GPAs with their scores on standardized tests like the SAT or ACT. By observing which correlations were strongest for your current students, you could use this information to predict relative success of those students who have applied for admission into the university. Prediction is one of the most important uses of correlations. Other uses include validity and reliability. Correlations are used to test the validity and reliability of psychological inventories, like personality, aptitude, skills, and so on. Reliability refers to the degree to which a test produces consistent results. Just as we enjoy having reliable cars, or cars that start every time we need them to, we try to have reliable, consistent instruments to measure student achievement. Instruments like classroom tests and national standardized exams should be reliable. It should not make any difference whether a student takes the assessment in the morning or afternoon, one day or the next. Validity refers to how well a test measures what it is supposed to measure. Let's imagine a bathroom scale that consistently tells you that you weigh 130 pounds. The reliability or consistency of this scale is very good, but it is not accurate or valid because you actually weigh 145 pounds. Since instructors, parents, and school districts make decisions about students based on assessments such as grades, promotions, and graduation, the validity inferred from the assessments is essential, even more crucial than the reliability. We've already discussed the advantages of correlations. It shows relationships between two variables and allows us to make predictions. The disadvantage is that correlations do not allow us to make causal conclusions. We cannot say that one variable causes the other. The reason is that we are simply looking at relationships and have not controlled for any other variables or plausible explanations for our results. Because of this lack of control, we can never say, for example, that higher levels of education causes higher income levels, or that smoking causes health issues. The temptation to make erroneous cause and effect statements based on correlational research is not the only way we tend to misinterpret data. We also tend to make the mistake of illusory correlations, especially with unsystematic observations. Illusory correlations or false correlations occur when people believe that relationships exist between two things when no such relationship exists. One well-known illusory correlation is the supposed effect that the moon's phases have on human behavior. Many people passionately assert that human behavior is affected by the phase of the moon, and specifically that people act strangely when the moon is full. There's no denying that the moon exerts a powerful influence on our planet. The ebb and flow of the ocean's tides are tightly tied to the gravitational forces of the moon. Many people believe, therefore, that it is logical that we're affected by the moon as well. After all, our bodies are largely made up of water. A meta-analysis of nearly 40 studies consistently demonstrated, however, that the relationship between the moon and our behavior does not exist. While we may pay more attention to odd behavior during the full phase of the moon, the rates of odd behavior remain constant throughout the lunar cycle. The only way to establish that there is a cause and effect relationship between two variables is to conduct a scientific experiment. Experiment has a different meaning in the scientific context than in everyday life. In everyday conversation, we often use it to describe trying something for the first time, such as experimenting with a new hairstyle or a new food. However, in the scientific context, an experiment has precise requirements for design and implementation. The experiment is a research method in which the investigator manipulates a variable under carefully controlled conditions and observes whether any changes occur in a second variable as a result. The experiment is a relatively powerful procedure that allows researchers to detect cause and effect relationships. Psychologists depend on this method more than any other. The purpose of an experiment is to find out whether changes in one variable, let's call it X, causes changes in another variable, let's call it Y. To put it more simply, we want to find out how X affects Y. In this context, we refer to X as the independent variable and to Y as the dependent variable. An independent variable, or IV, is a condition or event that a researcher varies in order to see its impact on another variable. The independent variable is the variable that the researcher controls or manipulates. It is the variable that the researcher believes will have an effect on the dependent variable. The dependent variable, or DV, is the variable that is expected to change due to the manipulation of the independent variable. In psychological studies, the dependent variable is usually a measurement of the participant's behavior. One way to remember the difference is the effect of IV on DV, or IV causes a change in DV. In an example research experiment on drinking alcohol and driving skills, the hypothesis might be consuming more alcohol will cause poorer driving skills. The independent variable would be alcohol consumption as measured by blood alcohol content, BAC. The researcher controls how much alcohol is consumed. After manipulating the independent variable, the researcher measures the effect of alcohol on driving skills. The dependent variable is driving skills, as measured or operationally defined by either the number of virtual crashes or how long it takes the driver to stop the car when an obstacle appears on the virtual road. So instead of letting participants actually drive, the researcher might measure their skills safely as they use a driving simulator or play a driving game on a computer. The most basic experimental design involves two groups, the experimental group and the control group. The two groups are designed to be the same except for one difference: experimental manipulation. The experimental group gets the experimental manipulation, that is, the treatment or variable being tested, and the control group does not. Since experimental manipulation is the only difference between the experimental and control groups, we can be sure that any differences between the two are due to the experimental manipulation rather than just chance. Participants are randomly assigned to experimental and control groups. With random assignment, all participants have an equal chance of being assigned to either group. Random assignment is different from random sample or random selection. Random sample is the method that gives every member of the population of interest an equal chance of being chosen to participate. Random sampling is the process of selecting people from the population to be in the study. Random assignment is the process of assigning people from the sample to be in one of the groups or conditions, experimental or control, of the study. To go back to our research example, the participants assigned to the experimental group will drink enough alcohol to reach a certain BAC level. The participants assigned to the control group will drink something non-alcoholic. The researcher then compares the effects of drinking non-alcoholic beverages in the control group with the effects of drinking alcohol in the experimental group, or more than one experimental group if the researcher includes several levels of BAC or blood alcohol content in the study. The logic here is that any difference in driving skills between these groups must be due to the alcohol consumption. Let's look at another research example. What if we were interested in the effects of sleep deprivation on memory tasks, where one group is kept awake for 24 hours and the other group follows normal sleep patterns? What is the independent variable? Dependent variable? Experimental group? Control group? I'll give you a minute. Write down what you think. All right, let's see if you got these right. The independent variable is sleep deprivation. The dependent variable is the memory task. Experimental group is the one that is kept awake for 24 hours. The control group is the one that gets the normal amount of sleep. How'd you do? All right, let's take a look at the advantages and disadvantages of experiments. So the advantages is that researchers have precise control over variables. Researchers can draw conclusions about cause and effect relationships, and this is a biggie. The disadvantages are that lab settings are often artificial. Not everything can be studied using experimental research due to ethical concerns or practical realities. Here's a quick recap of descriptive, correlational, and experimental research methods, their basic purpose, how they're conducted, what, if anything, is manipulated, and their limitations. In our next video, we will discuss ethics in research.